All right, here's a quick primer on how to calculate these things. This is a first view of my data points. This is for exercise number 1. The dots, dot 0, I had it for 4.95. And again, your data is going to look different. Okay, so this is just the data I took from my particular tape that and again, each of you have your own unique tape. I had to drop it each time, so there's like 35 different tapes out there. So all of you are going to have different data, depends on how you aligned it on your meter stick. So convert to meters. So the next column is delta x. What you do is you take the dot number 1, subtract off dot number 2. So in my case, I'm going to take 0.061 minus 0.0495 and put that in here, and then continue down. So again, that's why in the delta x, the first line is blanked off. So then I take 0.087 minus 0.061. That's 0.026. Then I do a couple of them just to get you an idea. And 0.112 minus 0.087. And they should be going up each time. It looks like there's a little bit of an issue right there. So 0.145 minus 0.112, and it's going up. So what I'm going to do, these numbers should be going up each time. Can you see that this number goes down slightly? They should be going up by increasing amounts. So they should be larger each time because you have an acceleration. So I'm going to go back and check these two numbers. And once I went back and checked it, sure enough, I did find that point number 1, I misread it. It was supposed to be 6.6. Again, be very careful when you're reading the meter stick. It was one millimeter above, the halfway point. So instead of adding realizing that it was already at 6.5, I just said it was 6.1. So then what we do is I have to redo these, and that'll happen. You just have to make sure that if you have something that looks like that, before you go on, just go back and check on your tape and make sure that the numbers look well. So this is 0.0165, and this one, oh, wait a minute. I think I'm putting it in the wrong spot. 0.066 minus 0.0495. That's this one, sorry. So the first one, that's 0.0165. I put in the wrong spot. And this one should be 0.087 minus 0.066. So again, remember, this is my data, not your data. So now you can see it goes from 0.0165, 0.021, and then this is 0.025. Let's see, this. Oh, and this one should stay the same. I don't know why I crossed that one out, because I didn't change these. I only changed this one. So that can happen in the error. So I'm going to rewrite these because it's a little messy. Okay. So that's better. Can you see how delta x gets bigger as time goes by? Okay. So the next column, it'll ask you for the time. Well, the time is the same. It's always 1/4 of a second. So to find the speed, this is the distance between the dots. To find the speed, the velocity, what you have to do is take each of these distances and divide it by the time. So remember, the time is always 1/4 of a second. So it's 0.0165 divided by 1/4 of a second, or 0.025 seconds. So the velocity in my first one is 0.0165 divided by 0.025. That's 0.66 meters per second. And again, you can put meters per second at the top of everything. And there should be meters on everything as well. So you do the same thing. You take 0.021, divide by 0.025. Again, the same time each distance, even though the distance gets bigger, the time gets smaller. So you can see the velocity is increasing. And that's because there's an acceleration. So again, one more, and then you guys will do the rest of them, 0.025. And again, remember, these are mine. This happens to be one that's easy. So you can see the velocity is increasing as the thing is dropping. And what you're going to do is you're going to finish up finding all these velocities. You should see a steady increase. And again, if there's any sort of discrepancy, if one goes down or up or something like that, go back to your original positions and look at your dots again. You probably did something wrong taking the data off your tape. So just make sure you keep your tape down until you finish all of these calculations. Then what you do is you plot out the velocity versus the elapsed time. So you start out at t equals 0. After 0.025 seconds, you're going this amount. After 0.05 seconds, you're going this amount, etc. So the elapsed time. You plot the v versus the elapsed time, find the slope, and you can find the acceleration. And your lab instructor will help you figure out how to do that.